Okay, we've talked about Newton's second law, which is the sum of the forces acting on an object is equal to its mass times its acceleration. Now, you've often seen this as F equals ma, but in reality, it's a vector equation. And in that vector equation, you've got the forces on the left-hand side and the mass and the acceleration on the right. And the sum of the forces points in the direction of the acceleration. Now, of course, this is the vector equation, and we should always start out from that. And then what we'll do is we'll put in signs in the algebra equation with positive being forward and negative being backward. Okay, so here's a quick example. We've got two forces acting on an object. F1 points to the right, F2 points to the left, and you can see the diagram already. And in the diagram, we've got the object, so we really want to draw a free body diagram with just the arrows and a dot representing the object. And we also put in a small marker to show us which way is positive, and we've used the normal up in which the positive direction is to the right. Okay, so we start out from Newton's second law. I've written it backwards this time just to keep things aligned with the equal signs a little better. Okay, so we write out the vector equation where we write down each of the individual forces. And notice that I'm adding both because I'm adding them as vectors. And here in the next step is where I throw in the positive and negative signs. So I've got the mass times the acceleration is equal to positive F1 plus negative F2, fixing each of those for the directions. Now, I have not put in a sign for the acceleration yet. I'll let that fall out from the actual problem. Okay, and if I do want to find the acceleration, I go ahead and just solve for that by dividing both sides by the mass. And now I'm ready to put in some numbers if I have them handy.